Okay, hey everybody, we're going to go ahead and get started now. So first of all, thank you so much for coming. My name is Emma and I'm the founder of The Young Expressionists. On behalf of the entire team, I'm super excited to kick off this first guest speaker event of 2021. But before I get started, I'm going to talk a little bit about our organization, TYE, for those who aren't familiar with us and what we do. So The Young Expressionist, or TYE as we like to call it, is a nonprofit organization dedicated to sharing skills and inspiring young students, such as many of you guys in the audience today are. We host a variety of fun classes along with events and guest speakers just like this one. We also have a writing contest going on right now, so if you're interested in entering, all information can be found on our website at theyoungexpressionist.org. So go check that out if you're interested. And of course, if you know anybody else who would potentially be interested, you can definitely share the event with them as well. And one last thing before we actually get started, if you're not on our guest speakers email list and you would like to be added, Jacqueline will be sending a link to sign up in the chat any moment. So there it is. So be sure to check it out and leave behind your email if you're interested in hearing more about us, our organization, registration updates, just like all of the fun stuff that goes on in TYE. So without further ado, we're pleased to introduce our guest speaker for today. So our guest speaker today is Helen Wu. Helen is a master's graduate student currently studying at UC San Diego. And today in the webinar, she's going to be going through computer science and kind of introducing herself, talking a bit about her journey, and also talking and giving some tips on you guys if you guys also want to start your own computer science journey. And like all of our guest speaker events, please don't hesitate to ask any questions you have and engage with the presentation. Feel free to unmute and participate. If you have any questions, go ahead and type them into the chat. We'll have some time at the end to answer them all. So everybody, without further ado, please give Helen a warm welcome, and Helen, go ahead and take it away.
Thank you, Emma. All right, so hi everyone. Welcome to my webinar called A Beginner's Guide to Computer Science. Today we will be talking about what computer science is and how you could start your own adventure with it, as Emma mentioned. And just a fair warning, this webinar is not about how to program or code, but what computer science is. So the plan is this. I'll briefly go over my journey with computer science, and then I'll go over the history of computer science, followed by what computer science is and how to get started. And I try to make it as beginner friendly as possible, but some concepts still might be a bit tricky. So feel free to stop me and ask whenever you have a question. All right. So a little about me and my journey with computer science. My first ever experience with coding was in junior year of high school, where I attended HS Hacks, which is a hackathon. I went in with absolutely no experience in coding, and my friends had to pull all the weight on that project. But while I didn't do much coding, I did get a better sense of what computer science was about. And then in the same year, I also applied and got into UC Santa Cruz's Cosmos summer program. And there I was part of the cluster that created video games. And this program taught me the fundamentals of coding, as well as indirectly the struggles and frustrations that may arise while coding. And then, well, after everything was done, the results, at least for me, justified my struggles and frustrations and solidified my love for coding. So not sponsored, but my experience at UC Santa Cruz's Cosmos was extremely positive, and I would highly recommend applying to their video game program or any program in general, honestly. So when college applications rolled around, I applied as a computer science major and was lucky to have UCSC accept me into their program. And during my 4 years of college, I attended more hackathons to apply and strengthen my skills as a computer scientist. And hackathons are a great place to learn more about industry applications of computer science. And there are so many great mentors at these events that can help you learn new concepts. And plus there's free food and swag, so what's there not to like? And then after graduating UCSC, I decided to pursue a master's at UCSD as a computer science major to expand my knowledge of computer science even further. And that's where I am now. And also the final bullet point, as you can see on this timeline, I'm also working with Emma at her startup called Quillmates as a full stack web developer, which means I work on everything from the web page to everything behind it. So enough about me. Let's get into the wondrous world of computer science. And what better way to start that than to very briefly talk about the history of computer science. In 1837, a mathematician named Charles Babbage, which we call the father of computers, introduced the world to the analytical engine, a machine that incorporated arithmetic logic, similar to that of a calculator. And working alongside him was Ada Lovelace, acknowledged by us computer science people as the first computer programmer with her algorithm to compute the Bernoulli numbers on this analytical engine. Around the World War II era, Alan Turing created the Turing Machine. And this creation was very important as this model proves that there existed limitations of machines, and specifically the part about machine computations. And from this discovery arose the idea of modern computing machines. And finally, in the late 21st century, Steve Wozniak and Steve Jobs, known for being the founders of Apple, popularized personal computers by making these computational machines more accessible for the average humans. So now that we know a little bit about the history of computer science, let's get into the question we're all wondering. What is computer science? When I say computer science, what do you think of? Anyone have any ideas? Okay, well, that's fine. It's totally fine. So when I say computer science, people who are unfamiliar with it might say, computers, hacking, maybe video games, androids, killer robots. And now these aren't necessarily wrong, but we need to dive deeper. These ideas are a result of computer science, but computer science itself is more about the process. So let's watch a video on what engineers at Facebook have to say about the definition of computer science.
Computer science is the art of teaching a computer what to do. I'll start with something similar. Like a screwdriver is a tool that is made to kind of turn screws, and on its own, it's useless. You have to take it in your hand and kind of turn it to make something happen.
A computer actually learns a set of instructions and actually transform that into a way of showing a movie or playing an audio file or delivering Facebook. And that whole study of how the computer thinks is computer science.
It's code, and so code is a bunch of symbols and letters, but it's really more like a language.
I got here from Puerto Rico, and I didn't know English, so I had to spend a lot of time trying to perfect my English. Programmers do the same thing. They learn new languages to do new things. They are inputting this language and these instructions into the computer so the computer can do what they want them to do.
Growing up, I was one of the very few people who had access to a computer around me. And I remember being bored one day and I picked up this book that was near the computer that said basic programming. And they had this really simple getting started, a hello world program that you could write in BASIC. And I remember writing it and recognizing that, wait, hold on, I just put this thing in and taught this computer how to do that, and it came back out. And I had my brother come in and use it. And he's like, oh man, you made the computer say hello? It's like, yeah, I did. Isn't that cool?
In our everyday lives, you speak language and you use that to communicate and instruct when you're around people. Similarly, a programming language is exactly the same thing. It's just a language that you'd use to talk to the computer.
And think about the first thing you do when you wake up in the morning. Let's say it's an alarm clock. There are instructions that somebody put into that alarm clock to teach it how to tell time, how to respond to you hitting the snooze button. You're walking out the house and you jump in your car and you start it. There are lots of computers in there figuring out how to turn the engine the very first time, how much gas to put in. This set of instructions that people have put into all these little devices you've used throughout your day just made your day that much easier to get through.
You want directions, or you're dialing a phone number, you're actually interacting with a computer to solve the problem at hand. That's computer science and programming right there, every day, in your hand.
Programming and computer science is one of the best ways to have impact in the world. There is no other career, no other field where you can touch so many people's lives with just a simple software or a simple app. And it's specifically also important for diverse communities to be involved because of the fact that computers are everywhere, programming is everywhere, and we want an equal representation when we are building programs.
We need people who have a broad range of perspectives to find different solutions.
Creating products for the people, you need to be the people. And if we hope to have products out there that really serve our needs, we need to be involved. Programming, learning computer science, and being part of the creation process of this new wave of innovation.
All right, so as you saw in the video, some words and ideas were repeated over and over again. So, feeding a computer a set of instructions, finding solutions to a problem, programming. And these are all what computer scientists do. And they all stem from one concept, acknowledging an issue or problem in the world and solving it using a machine. And this could range from simple addition problems using a calculator to programming video games, such as Fortnite. But let's take a look at a simple example. So we're given a sorted list of numbers. You can see here 1, 3, 5, 7, 9, 11, 13. And we want to find the number 11. So as a human, how would you find the number 11? And this is a question asked to all of you guys. How would you guys go about finding this number 11?
Okay, I got a private message in the chat and they said they would just look at it and they would just instantly find it.
Oh, yeah. So, normally a human would just look at the list. If the list is small enough, they'll instantly spot the number 11. However, a computer can't just look at the list all at once like a human can. It can only look at the number one at a time, like 1, 3, 5, and etc. So, sorry, I seem to have skipped ahead and over. Yeah, so a human would just look at this list and find the number 11. However, a computer can't do that. So what a computer does is it looks at the numbers one at a time. So look at 1 and it goes, is 1 the same as 11? No. Is 3 the same as 11? No. 5, no, and it keeps going. And then finally it looks at 11 and goes, is 11 the same as 11? It is. And that took about 6 steps, or that took 6 steps, not about 6 steps. So hooray, we did it. So now the computer can locate any valid target number. However, computer science is not simply just solving a problem, but optimizing the solution as well. So here's another question. Can we do better than 6 iterations? And although not intuitive, we can find the number quicker by removing half of the list one step at a time. So let's take a look at that. So we have the list here, and then we find the median of the list, which is 7. And now we ask ourselves, is 7 greater than, equal to, or less than 11? And because 7 is less than 11, and because this list is sorted, we know that the left half of this list does not contain the number 11. So we can remove that. And now we're left with 9, 11, and 13. So we repeat that process. Find the median. The median is 11. Is 11 greater than, less than, or equal to 11? And it's equal to 11. So hooray, we found the target number, and that only took 2 steps. And in computer science, we call this a binary search. It's a pretty cool concept. Now, this was a very simple and boring example, but this is essentially what computer scientists do. We find a problem, solve it, and then find ways to optimize it, not necessarily in that order. A more interesting example would be like programming a PC game, and then along the way, fixing bugs and optimizing the code so the game can run faster and smoother. And I think, if anyone knows Bloons Tower Defense, Tower Defense game, they have like 6 iterations of it. And you can see how like they improve their craft each time. So like this is like 1, this is I believe 4, and then 6. So now that we know what computer science is, let's move on to the different applications of computer science in other fields. So computer science is a field good for interdisciplinary studies. And for those who don't know what interdisciplinary means, it means the combination of 2 or more, academic disciplines into one. So for example, let's take a look at the 3 sciences: biology, chemistry, and physics. For biology, people who want to study both biology and computer science can major in a major called bioinformatics. As a bioinformatics professional, some possible work you can do is managing the biological and genomic data in a database, or discovering new drugs using reconstruction of genomic data on a computer. And for chemistry, you can major in chemoinformatics, though I have to say it's not a mainstream major. A lot of schools don't have it. And some jobs that stem from this major include like reconstructing molecular compounds on a computer, or maybe using graphs and machine learning to discover potential malevolent drug-to-drug interactions. And there's finally physics, where you can use computer science to produce simulations, such as reconstructing the solar system, or combining physics and computer science to create flight simulators, or even knowing a bit of physics so that you can help video game programmers program the physics simulation better. And if you're not into sciences and you're more of an arty person, there are also more opportunities for you. Digital art is becoming more and more popular nowadays, and users are always looking for a more realistic experience of drawing using computers. And you can help develop an art software, Photoshop or Paint.si, or if you're more into like animation and computer graphics, you can work on improving Blender or Autodesk Maya. There's like so many options out there. And if you're not into the sciences or art, but you like business, there are options for you as well. So there are management softwares for customer relationship management, where you design a program to help companies keep track of their customers. Or you can develop a platform like Jira to manage team members and tasks in an organization. Also, did you know that you can program on Excel? Yeah, so you can actually program Excel to, create a button and have it calculate profit or increase supplies on a spreadsheet. And you can also use it to scrape the web for data, and that's what we call web scraping. So now that we've gone over everything what computer science is, you must be going, wow, I love computer science. So how do I get started? And that's an excellent question. For the most part, we're all problem solvers in our day-to-day lives. So that's checked off the list. What you need now is direction and some programming experience. So here are some logos for some of the more popular programming languages. HTML is not a programming language, but it is a very popular markup language for displaying objects on a web page. And as you can see from the slide, there are so many languages to choose from, and that may overwhelm you. However, just know that for the most part, programming languages have the same logic. So if you learn one, you should be able to pick up pretty fast on the other ones. And learning programming languages is pretty similar to learning foreign speaking languages, as like one of the ladies in the video said. But like both types of languages requires the learner to understand the differences in the language's grammar and syntax. For example, we all know English, and in English, adjectives come before the noun, like brown bear, right? However, in French, not all adjectives come before the noun. In fact, most come after the noun. And another example would be Spanish's upside down exclamation mark. So in English, the punctuation is only placed at the end of the sentence, but for Spanish, for certain punctuations, it comes before and after, like the punctuation mark. And programming languages are the same. They have their own unique quirks that you must be aware of when programming. So let's compare 3 of the more popular programming languages, Java, Python, and Go. So I won't be delving too much into the code, but if you would like me to go over how the code works, feel free to ask me during our Q&A portion. So here's the code to solve our problem of locating the target number in a list in Java. So as you can see here, Java likes using curly brackets, lots of curly brackets, as you can see. And they also like using parentheses. See right here, parentheses, 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 parentheses. And for lines of code, they ended with a semicolon, as you can see here. Now, here's the same algorithm, but in Python. So as you can see in the Python one, the curly brackets disappeared and they're replaced by colons. And as well, for the lines of code, it doesn't end with a semicolon. It's missing a semicolon. And it's also missing these parentheses around these statements here. And for Go looks really similar to Java. There's curly brackets, they're back. However, unlike Java, it doesn't have parentheses and it doesn't have semicolons. So that part is very similar to Python. So as you can see, how you format your code is very important to that specific programming language. And if you don't format it correctly, the code may not compile or run. So now that I'm done giving a brief overview of the aesthetics of the language, let's talk more about the programming languages themselves. So first, let's talk about Java. Java is the classic starter programming language. You would see it in your AP CS class in high school. I would say it's pretty easy to learn. It's one of the easier languages to learn. One trouble that you might run into is learning about the data types. So as you can see here, you can see that there is an int in front of this target. Now, int is short for integer, which is whole numbers that are both negative and positive. So in Java, you must have a data type in front of your variables. However, in Python, Python, I would say, is an easier language to learn because Python, you don't need to declare those types. So as you can see in front of this variable, there's no int. And we call that dynamically typed. So before compiling and running your program, you don't need to provide those data types. And again, that's why I feel like Python is an easier language to learn. And also it's becoming more and more popular. For example, in my college, they switched from Java to Python as the starting language for students to learn. And finally, Go. So Go is not, you guys probably haven't heard of Go because Go is mainly used to program servers and systems. And it's pretty similar to Java. It's statically typed. You have to declare a data type. So I would say it's about as easy to learn as Java. But all programming languages for all 3, I would say they're pretty easy to pick up, but very difficult to master. So that was a lot to take in. And you must be super overwhelmed right now. But don't worry, there are ways to take this one step at a time. And one good website I would recommend is Codecademy. It's free with additional paid features such as more in-depth lessons, projects, and quizzes. But the free portion is still a great resource. And you get a step-by-step guide of the language and all the fundamentals required to program in that language. And another great tool is YouTube. There, you have follow along tutorials that might go more in depth about the language and why the language does what it does. And if all else fails, the Google search engine is your friend. Whatever question you have, just type it in, and the search bar hopefully will spit out millions of results for you to choose from. And there's just so many ways to learn and start your computer science journey, and so many useful resources out there to help. So don't be afraid to take that small step forward, and maybe one day you'll solve some of the world's biggest unsolved issues using the power of computer science. Thank you.
All right, so now it's going to be our Q&A session. So if you guys have any questions whatsoever throughout the entire presentation, or if you kind of just like think of any questions you want to ask, you can feel free unmute, kind of like talk to us, or if you don't want to talk, you can totally type them into the chat, and I'll be reading them from the chat because some do come in as private messages. So we'll be spending a few minutes just answering any questions that you may have.
Oh, I totally missed the chat. I'm so sorry, guys.
Okay, so I got a chat message. It's a private message, but the question is, what classes did you take to become a CS major? I'm assuming in high school.
Oh, funny story. So I didn't take any CS classes, but I would recommend, AP CS. That is one way to start learning CS. But there's also high school hackathons that you can attend. They're pretty beginner friendly. You don't have to know, but you do have to apply. But you don't have to know computer science to get in. And that's also where I kind of developed, my understanding of computer science. And it's a great place to, find people who have similar interests and then code something super cool. And also you get free food. Yeah, so you can also do that. And again, I also mentioned, it's not a class, but the Cosmos summer program, I think there are quite a bit of summer programs. I have to do more research about that, but I would recommend Cosmos. It's also beginner friendly. You don't have to know how to code to apply and get in. And they have mentors there who would teach you how to code. But yeah, there's not many courses you can take during high school for CS. It's all electives.
Okay, another private message. I mean, like what classes in college, I guess. So that's my bad.
Oh, classes in college? I mean, in college, it's more restricted because you have to take some courses. I mean, I guess for the most part, I took an intro to Java course, but I think most colleges now would do like an intro to Python course. There's also a little bit more advanced, but there's also courses introducing you to the different algorithms you can use to solve problems. And that's also a very important class to take to learn about computer science. Yeah. And then of course there's also like focus classes, right? Like for AI or for computer networks. There's also focus classes. But to learn computer science, I would say, yeah, like take an intro course to first learn a programming language, and then start learning about data types and algorithms. Yeah.
Cool. And another question in the chat, well, kind of a question. Do you have any web development tips?
Oh, honestly, nothing specific. It's mostly just searching up problems that you run into on Google, typing it in, going to probably Stack Overflow, which is a website dedicated to like computer science questions. And just Googling the answers. And that's honestly, I think how most people learn computer science. They are given a problem and they just Google it, and then they find an answer. They tweak it, to match their problem. Yeah, there's not that many tips. but yeah, like again, if you do need help starting, YouTube is a great resource. I started with YouTube.
Yeah, cool. And Willow, I see you have your hand raised. Do you have a question?
Yeah, I was wondering what's like the daily life or like the routine of like a college you know, CS major. Like what do you do in a day? Like the assignments, the type of assignments you get, and like maybe if you've ever had a job, like what do you do at that job?
Oh, great question. Yeah, so college, it was because okay, so I was on a quarter system. I still am. There might be differences between quarter and semester. For the most part, quarter, it was you take 3 classes in total. So it's classes are like the least amount of time. The most amount of time you'll spend doing computer science stuff is like for their homeworks, and their homeworks, unlike high school. So like in high school, I felt that homeworks were assigned to you like every single day. It was like busy work. For college, there's really no busy work, and assignments are, at least for computer science assignments, usually they're due in about 2 weeks. Yeah, so you do have the time to actually like rest and like do stuff that you normally probably wouldn't be able to do in high school. But also, if you do want to succeed in that class, though, usually you would take some time to read up on the textbook and do more research about the topics covered in class by yourself. And so I would say my day mostly consisted of just going to class, reading the required texts, you know, go doing some more research about the required texts, like maybe some vocabulary words that I didn't quite understand, and then also working on the homework. But yeah, it like although it sounds like a lot, you still have quite a bit of free time, I would say. And as for job, I mean, I only worked on an internship before, but internship wise, it's really just you spend the majority of the time understanding what you're trying to do. So for example, if you had a problem, it'd be like, I guess 40% of the time just looking up how you would go about solving the problem, and 20% of the time coding it. And then I guess that leaves about like, I don't know, 40% of the time debugging it. So yeah, so like debugging as well takes up more time, I believe, in my opinion, than actually coding it up. And yeah, is there any question about my answer, or did I answer everything?
Yeah, I see a thumbs up, so that's good.
Okay.
And another private message in the chat. How is coding a website or web page different from creating an app?
So they're the same process. At least in my opinion, they're the same process, but you use different software sometimes. Like for example, for web development, you have different frameworks such as Vue, Angular for front end, and then for back end, there's like, wow, I'm blanking, like Express.js. Like there's like different software frameworks you use for like, that's for web. And then for app, depending on what you do, like if you want to make an Android app or like an iOS app, I'm assuming app as in like mobile app, you would use like Java, like I forgot what it's called, Android SDK, I believe, or something for Android apps. And then there's something called Xcode for mobile apps. But for the most part, they're the same because apps, web pages, they all need, a front end where the people can, interact with it, and then a back end that stores all the data. So yeah, so there's not much difference. The only difference is like the programming language that you're using or like the software that you're using. Yeah.
Very cool. And I think one more question in the chat that literally just came in. So, well, you kind of like mentioned it in like your previous answer, but what is a framework?
Yeah, so a framework, it's very hard to describe without including other terms in here, but pretty much a framework is like a foundation that you work from. So, usually you don't want to be messing with the machine language. You don't want to be messing with zeros and ones. You don't want to be messing with like lower level programming stuff. You want to have a starting point where you can actually understand it. And like a framework kind of is that, like it's a layer that allows you to not worry too much about what's going on beneath the surface and more about what's going on like above the surface, so you can actually program out what you want to program out. Like for example, a web page. Like you don't have to worry about like, oh, how does, like I type in like CSS 15 pixels and then behind the scenes, like it's like shifting at 15 pixels, but I don't know how to code that shifting part. I just need to type in 15 pixels and it'll just do it for me. It's like a framework is kind of like that thing, if that makes any sense.
Yeah, so it's kind of like the foundation for like programs. So you like program on top of it.
Kind of, yeah.
Okay, and I think the last question for today, because we don't want to keep everybody too long, how long does it take to build a website? And I know this is a pretty general question, but like best estimate, I guess.
Oh, well, it depends on what your scope of the project is. So if you want to build a static website, or if you want to build something, I guess, less interactive, it'd be pretty easy. Okay, I shouldn't say pretty easy, because starting from like, if you have no experience, I would say coding one page might take you about a month. From like learning the language to understanding the framework you need to use to actually building what you envision. Yeah, but I feel like that's a very generous estimate. Yeah, so it depends on like how much time you put into it. But like if you, let's say, put in like, I don't know, 5 hours a day, that's a lot actually. Like 4 hours a day, I don't know. But you put in 4 hours a day, let's just say maybe in a month you can learn it and be able to build it. But that's also very biased on my part because I know how to code. So yeah.
Yeah, cool. So, like you mentioned, that was basically the last question for today because we definitely don't want to go for too long. But if you have any other questions or just kind of want to reach out and connect with Helen, we'll include her contact information in the email we'll be sending out right after this webinar. So if you haven't joined our email list, be sure to drop your email in the form that Jacqueline sent, I believe, at the beginning of the webinar. And so basically, thank you all so much for coming. We hope you learned a lot and enjoy the presentation. A big thank you to Helen for actually agreeing to come present. But other than that, we'll see you next time.
Thank you for having me. Thank you, everyone.